Today's lecture is on the rate equation for the complex reaction, and I will give you the reaction coordinate, and then we will apply all the things, to problems asked in the previous years, either in the GATE or in the CSIR examination. Given NO plus BR2, a fast one, equilibrium fast one, NOBR2, and NOBR2 plus NO, a slowest step, 2NOBR. What is the rate law equation for this? The final answer, I am needed, not the intermediate rate law equation. After removing the intermediate species present in the equation, the final equation I am need of it. Work it out. You should be able to apply which is the intermediate species, which are the products, which would be the reactants. Reactants which would be the product or you sum up all the steps given, finally you will get the stoichiometry of the reactants. If you are not able to understand this, sum up the NOBR2, then sum up it 2NO plus BR2 giving 2NOBR. Therefore, from this you can also find out which is the reactant and which is the product. Nitric oxide and bromine. What is the rate law? Rate is equal to K into NO, concentration of NO square and the concentration of bromine. What is the order of the reaction? Total order is third order, and second order with respect to NO, first order with respect to bromine. And we will give you one more problem. Here is the slowest step, therefore rate determining step. What is the shortcut we are going to use is apply the first the rate law equation for the slowest step as K3 into concentration of COCl into concentration of Cl2. Which is obtained is a fast equilibrium, therefore you can make use of the equilibrium approximation. Here K2 by K minus 2 is equal to concentration of COCl by concentration of CO into concentration of Cl. Therefore, COCl can be written as K3. COCl concentration is equal to K2 by K minus 2 into concentration of CO and concentration of Cl. Therefore, K3 into K2 by K minus 2 into CO, Cl into Cl2. Whether it is a final rate law equation or not, tell me. Final rate law equation or not? Nobody else there?
No, sir.
No, why it is not a final rate law equation?
Cl is there.
It is the intermediate Cl is there, and the Cl should be replaced, and the Cl concentration, it is in the equilibrium formation of this one. Is apply this one, that equilibrium constant K, equilibrium constant determination K 1 by K minus 1 is equal to, write down the equation, சொல்லுங்க பார்க்கலாம். K1 by K minus 1 is equal to your concentration of chlorine atom square by the concentration of chlorine molecule. Therefore, concentration of chlorine atom square is equal to K1 by K minus 1 into concentration of chlorine, or the concentration of chlorine. Here only chlorine atom is there. So take the square root. K1 power half, K minus 1 power half, and the chlorine concentration power half. Substitute, we get K3, K2, K minus 1 power half into concentration of COCl2, Cl2 power 3 halves. Whether this is the final rate law equation or not.
Yes, sir.
Yeah, why? Because it involves the concentration of the stable species, chlorine and carbon monoxide. Now you can now tell what is the total order of the reaction, what are the individual orders, and what is the overall Arrhenius factors. Now the total order is 2.5 order. With respect to chlorine is 1.5. With respect to carbon monoxide 1. And what is the overall rate constant? It is given by, overall rate constant is given by K3 into K2 into K1 power 1 half and divided by K minus 2 into K minus 1 power half. Now, anybody tell me what is the overall activation energy for this complex reaction, for the Posigen reaction? E overall is equal to, tell me the answer.
E3
E3
plus E2
plus E2
plus 1 by 2
1
minus
minus
E minus 2
E minus 2
minus
minus
1 by 2
1 by 2.
E minus 1.
Yeah, yes, you are correct. Therefore, no necessity of going and deriving this one. This is the shortcut. If any problem is asked like this, you can immediately tell the answer. And I will give you the reaction coordinate, and then we will apply all the things to problems asked in the previous years, either in the GATE or in the CSIR examination. What is the reaction coordinate? I think you might have studied the reaction coordinate. It is nothing but the potential energy diagram with respect to the proceedings of the reaction as well. Generally, a reaction coordinate is given by this potential or energy of the species, and it is called a reaction coordinate, in which the time axis may be given or some other thing may be given. Therefore, we call this a reaction coordinate. So how in time, in terms of time, it may be given, or in terms of percentage, it may be given, or we call it as a reaction coordinate, that is X coordinate, Y coordinate. As we tell, this is called reaction coordinate. We will see first for a simple elementary reaction. In the elementary reaction, this is the average energy of the reactants. Let us assume if the reactant is A only, then it is a R, or we will put it as a R here. Therefore, it is reactant R, or the reactant may be A plus B, means here we will give the average energy of A and B as given. And the species, all the species present in the reactant would not undergo reaction because the energy requirement or the threshold energy of the molecule should be here. It should be higher, and those molecules which attains the threshold energy can undergo the reaction. Last class we have seen. Only a fraction of the molecule is attaining this energy. Therefore, those molecules would be attaining this one and then undergoing a reaction to give the product. And this is the product. The product energy. What is the difference between the product energy? The product energy may be lower than the reactant energy. Then according to the thermochemistry, the excess energy would be emitted in the form of heat energy. we call this the exothermic reaction. And what I have written in the diagram is this reaction coordinate diagram is for exothermic reaction. And those molecules for which is in need of energy from the average energy to attain the threshold energy, we call it as the energy of activation. This much amount of energy is required to activate the base C R molecule to an activated state. Here this state is called activated state or intermediate state or transition state. Here why it is called as a transition, here reactant is going to be transformed into product for activated complex or transition state complex, etc. may be given. And this is the energy of the reactant, and all the energy of activation would be calculated with respect to the energy of the reactant. And now the product energy is lower than the reactant energy to this extent. And this we call as the heat of reaction. Here excess energy is released, therefore it is called exothermic reaction. And for a reaction, for an endothermic product formation, the nature of the curve would be just like this. Reaction coordinate, this is the average energy of the reaction. And the product energy, if it is the product energy also equal to the reactant, and delta H would be equal to 0. On the other hand, if the product energy is above the reactant energy, then this is a reaction coordinate, and this we call it as energy of activation, because energy of activation is always calculated in terms with respect to energy of the reactant, and the difference in energy between the reactant and product we call as the delta H. This is an endothermic reaction. It's an endothermic reaction. This is in need of high energy. Okay, this is for a simple or elementary reaction. We will now see a reaction coordinates for the complex reaction involving two steps product. This is the energy of the reactant. This is the energy of the product. Here we are giving that this is an exothermic reaction. Two steps are there. In the first step and second step. Of these two steps, one step may be in higher energy, another step may be in lower energy. Let us assume that the first step is having higher energy and the second step is having lower energy like this. And this is the reactant. What is the activation energy for this process? The first process, this is the activation energy. What is the activation energy required for the second product? This is the activation energy for the second one. And this is the first intermediate. Reactant forming the intermediate then forms the product. Here, look out these two energy of activation. This is transition state 1, this is transition state 2. Therefore, when two steps are there, two transition states or two activated complexes, and two P could be obtained, and each P corresponds to the maximum energy required to, or the threshold energy required for carrying out that process. And of these two, which is having highest energy, that is step is taking place very slowly. And that step should be the rate determining step, because rate determining step is that step which is taking place very slowly. And from the diagram itself, we can say this step is the rate determining step. Why it is called a rate determining step? Because energy of activation is very high. On the other hand, we will draw another kind of reaction coordinate. Here, look at this. And this is a reactant. This is the first transitions of time. And this is a second one, a second reaction. This is an intermediate. first activated complex, second activated complex, and what is the energy of activation? Which would be having the energy of activation, whether the first state or the second state. Second state is requiring higher activation energy than the first state, and therefore this is a rate determining state. Second state is the rate determining state. If this is the case, like this, it is smaller in energy than the first state, is there will definitely there is an equilibrium would be obtained with the intermediate. There is a equilibrium is obtained with the intermediate when the second step is a return state. And if the first step is one, the intermediate and the product would be in the equilibrium. There is one more case here, reactant product. Here, this is one step, this is another step, and a product at all the time. We have drawn the reaction in coordinates for an exothermic reaction. How you obtain exothermic reaction? Reactant is in higher energy, product is in lower energy. We have drawn the reaction coordinate for this. Looking into the diagram, we say that the first reaction as well as second reaction is a two-step process. They are taking place almost the same rate. If the same rate is there, no step is in equilibrium. Therefore, equilibrium approximation cannot be applied for this. You should apply steady state approximation for this. For this type of equilibrium reaction, when the second step is in higher in energy, the first step would be in the equilibrium and vice versa. Therefore, you can apply it for a two-step process. Similarly, you can write for a three-step process. For a three-step process, what would be this? This would be lowest, and the highest. This is the one possibility. And this is the highest, and this is the lowest, and the intermediate, another possibility. And this is one. And this is higher, and this is the one. Or you can put two may be equal and the third one is but looking into this, the highest peak intermediate, we say that is the rate determining states and so on. If you understand this concept, now take down the problem. Identify the transition state, which determines the rate of the reaction, from the free energy diagram. The first, second step reaction, third step of reaction, fourth step of reaction. Option A, first step is the rate determining, B is the second step, C is the third step, and D is the fourth step. Which one is the rate determining step? Tell me.
Fourth one.
Fourth one, because it is higher energy, therefore this is the simplest one. And don't expect such a easiest question in your CSIR examination. Now we will go for another type of reaction. Take down this. For an exothermic chemical process, occurring in two states, as follows. First state, A plus B giving X slope to second step. X giving AB fast. AB fast. The process of the reaction. The process of the reaction can be best described by அப்படின்னு போடுங்க ஆப்ஷன் ஏ படம் போட்டுக்கோங்க ஆப்ஷன் ஏ போட்டிங்களா அடுத்தது ஆப்ஷன் பி ஆப்ஷன் சி அடுத்தது ஆப்ஷன் டி which is the correct one இது எல்லாமே நீங்க எழுதிக்கோங்க இது RR PE potential energy this is the reaction coordinate reaction potential energy and potential of the diagram which is the suitable reaction coordinate diagram for this one.
C.
See,
Option C.
why you have taken this one? Two-step process, therefore it is not correct one. And it is the slowest step, which is the slower here. This is the slowest step, therefore this is not correct. Here there are two slow, here also possible, this is also possible. But you have chosen that
Endothermic and exothermic.
this is an exothermic reaction, this is an endothermic, but given as an exothermic reaction. Okay, then write down, select the correct diagram for an endothermic reaction. Select a correct diagram for endothermic reaction. Which proceeds through two steps. Which proceeds through two steps. With the second step is the rate determining step. With the second step is the rate determining step. Option எழுதிக்கோங்க. Which is the correct answer? A or B or C or D?
D.
D is the correct option. Why you have chosen there? First, it is an endothermic. It is a exothermic. Sorry, exothermic. It is a endothermic. Here delta H is equal to 0, and it is a endothermic. Okay, and the second step is the rate determining. Therefore, this is a correct option. Okay. We will now not hereafter we are not going to see such type of problem. Instead, we will go for another type of problem. Take down the problem for a complex reaction. A giving products. The rate constant is K. EA1 is equal to 180 kilojoule per mole. EA2 is equal to 80 kilojoule per mole. E3 is equal, EA3 is equal to 50 kilojoule per mole. The overall rate constant is related to individual rate constant. By the equation, K is equal to K1 into K2 by K3 power 2 by 3. The activation energy bracket in kilojoule per mole for the overall reaction. For the overall reaction is yes, work out
140.
D.
140.
Yes, you are correct. Now take down the problem to be exercised in your home. Take down the problem. The rate law for one of the mechanisms for the pyrolysis of acetaldehyde. For the pyrolysis of acetaldehyde at 520 degrees centigrade. At 520 degrees centigrade and 0.2 bar, 0.2 bar is rate is equal to K2 into K1 by 2K4 power half into acetaldehyde power 3 by 2. The overall activation energy E in terms of rate law, A, E of A2 plus E of A1 plus 2E of A4, B option, E of A2 plus half E of A1 minus E of A4, C, E of A2 plus half E of A1 minus half E of A4. The option E of A2 minus half E of A1 plus half E of 4. And here one small difference is, the difference is nothing but the constant is present here. Ignore the constant, whatever may be the constant, ignore it and find out only the K values and suitably give the answer. Okay, and check it in your home. And now I am going to give another problem which is asked in the year 2004. A certain reactions proceeds in a sequence of three elementary states with rate constants K1, K2 and K3. If the observed rate constant is expressed as K observed is equal to K3 into K1 by K2 power half. The observed energy of activation of the reaction is take down the options.
Option D.
Okay. And take down the year 2009 it is asked. In the reaction mechanism given given x plus y k1 EA1 k2 EA2 is it giving product k3 EA3. K1's case, K1's like case, represent rate constants, EA's activation energies, and K2 is very, very greater than K1. K2 is very, very greater than K1. Two questions. First question. The overall rate constant for the formation of P, the overall rate constant for the formation of P can be expressed as option A, K1, K3 by K2, and B, K2 by K1, K3, C, K1 by K2 plus K3, D, K1 by K2 minus K3. This is the first question asked. The second question asked is the overall activation energy for the formation of P can be expressed as E of A1 into E of A3 by E of A2. E of A1 into E of A2 by E of A3. C. E of A1 plus E minus E of A2. D. E of A1 by E of A2 plus E of A3. And looking into the answers for the energy of activation, so overall activation energy, you can immediately tell what is the answer for the first problem, what is the answer for the second problem. Looking into the problem, not you are necessarily deriving for the equation for the rate law, and using here you should apply the steady state hypothesis. Even after applying this, you should apply the condition that K2 is very, very greater than K1. Therefore, K1 can be neglected in comparison with K2. Apply the conditions. Finally, you will arrive at the rate law from which you can determine what is the K overall. But I am, instead of going into that way, I am giving the same problems are given in the 2009, the GATE examination, I think so. And what is the answer for it? பார்த்த உடனே கண்டுபிடிச்சு சொல்லுங்க பார்க்கலாம்.
Option A and option C.
ஆப்ஷன் ஏ அண்ட் சி. எப்படி கண்டுபிடிச்சீங்க? எப்படி கண்டுபிடிச்சீங்க?
Option C is
Only
meaningful.
option C meaningful, மிற்றதெல்லாம் meaningless. இல்லையா? It is not. If it is correct, what would be the corresponding K? Yes, you are correct. இது வந்து ஹை மார்க்ஸ் கொடுத்துருக்காங்க அந்த காலத்துல. But this is the one. Okay, the question that is asked in the year 2014, a reaction. A plus B plus C giving D follows. The mechanism. Follows the mechanism. A plus B with a reversible arrow AB, and A plus B plus C giving D. In which the first stage remains essentially in equilibrium if delta H is the enthalpy change for the first reaction and E naught is the activation energy for the second reaction. Activation energy for the second reaction. The activation energy of the overall reaction will be given as A E naught, B, E naught minus delta H, C, E naught plus delta H, D, E naught plus 2 delta H, which is the correct answer. The exercise in our home. And we will go for some other problems. Now, 2012 question, a simple one. You can give an answer for this. For a reaction involving two states, G with reversible arrow giving 2H and G plus H giving product. Assume that the first stage attains equilibrium rapidly. The rate of formation of P is proportional to option A, concentration of G power half, B, concentration of G. It is also a gate question, I think so. Concentration of G power 2, D, concentration of G power 3 half. Once again, you have to derive the rate law equation. Finally, you can come to the conclusion whether the equation is proportional to this concentration or this and this and this. And work out the problem and tell me the answer. Here you are asked to calculate the rate of formation. What is the rate of formation? dP by dt is equal to K. It is not given anything. Here you assume it K into concentration of G into concentration of H. Here G is a reactant, H is an intermediate. Therefore, you have to substitute the concentration for H. Here equilibrium is given. Therefore, you can apply for the equilibrium. Let us assume the equilibrium is capital K. And here there is no harm in assuming that it is small k. Then capital K would be equal to the concentration of H power H square by the concentration of G. Therefore, concentration of H would be equal to the K power half into G power half. Substitute this in this equation. The rate law would be equal to K into K power half into G into 3 by 2. Therefore, now your answer is coming out automatically. And now we are going to see in 10 minutes another small topic. Then we will end up the session, the salty effect. So far, no problem is answered in the salty effect, but there are chances to be appearing in the next coming one. Salt effect. Salt is nothing but the electrolyte consisting of the cation and the anion. The cation and the anion would affect the rate of the reaction of reaction in which the reactants are in ionic state. Whenever reactants are in ionic state, or one of the ion is in ionic state, or both the ions are in the ionic state, the rate of the reaction would be affected by the addition of an electrolyte. And the salt effect is of two types. One is called the primary salt effect, and another is secondary salt effect. The primary salt effect affects the rate of the reaction by affecting the activity coefficient. By affecting the activity coefficient. The secondary is a salt effect affects the rate of the reaction by incorporating additional reactant ions. Additional reactant ions. That's the difference between the primary salt and the secondary one. Here there will be a derivation for the effect of the salt on the reaction rates based upon the Defay-Huckel limiting law and the ionic strain. I'm not going to derive this at all, but I will give you the final equation to be used for working out the problem. What is that equation to be used? That equation is log K is equal to log K naught plus 1.02 into EZA, EZB into root of I, where I is the ionic strain. You know how to calculate the ionic strain, etc. I'm not going to discuss the calculation of the ionic strength whenever an electrolyte is given, when its concentration is given, how to calculate the ionic strength. Here ZA is the charge over the reactant A, ZB is the charge over the reactant B. They have to decide this, and before seeing how they are all affecting the nature of the graphical representation, we will say K is the rate constant due to the primary salty effect. The rate constant of your reaction due to the salty effect. K naught is the rate constant in the absence of salty effect. In the absence of salty effect. This is K due to the salt effect in the absence of salt effect. And ZA, ZB is the charge over the reactants A and B, and I is the ionic strength. And if you see this, first we will see the graphical representation, and then we will go for how many types of problems that can be asked using this equation. But so far no problem is asked, but it can be asked. We will represent this. The log A, the rate constant in the absence of a salt effect is a constant. K is going on changing with respect to the amount of the salt added or electrolyte added into the reaction mixture. ZA, ZB for a given A and B, it is a constant. Therefore, two variables is log K and I. Therefore, you can plot log K versus root I, the ionic strain. You will get a straight line because it is in the Y, it is in the C, and here this is going to be changed M into root I. What is the slope of the line? The slope of the line, M, depends upon the charge over the ion A and B. And in what extent it will be affecting the graphical representation. We will see it. Let us consider a reactant C is A and B. And what is the slope, nature of the slope, whether the slope is எப்படி இருக்கும் அந்த plotல அப்படிங்கிறது, it will be looking like what is. Then what happened to the rate of the reaction. If this is like this, what happened to the rate of the reaction? Now let us having two reactants A and B. The possibility A is a cation, B is also a cation. Therefore, ZA is plus, ZB is also plus. The charge over the cation and A and B we have given. ZA is the charge over the A, ZB is the charge over the A, and ZB is the charge over the A. It determines the slope of a reaction. Now let us assume ZA and ZB are having both same sign, that is plus plus or minus minus. Now the net multiplication of ZA, ZB will give you a positive slope. And for such a reaction, the slope, the straight line would be with a positive slope. And the slope is equal to ZA 1.02. We can simply omit is 1.02. It is equal to ZA into ZB. Positive ion, or negative ion. Same charged species would increase the rate of the reaction as the ionic concentration increases. Therefore, what is the rate of the reaction? It increases with the addition of electrolyte. This is one possibility. Another possibility, Z may be plus charge, ZB there is no charge, or it's a minus charge, there is no charge, or ZA is zero charge and positive charge on B or negative charge on B. On both the cases, all the four cases, if you multiply ZA and ZB, the slope is equal to 0. The slope is equal to 0 for which reaction? The very first class I have told, for an equation for a line, slope is equal to 0 means it will be parallel to which axis? It should be parallel to which axis?
X-axis.
X-axis.
X-axis. Therefore, this would be like this. For here slope is equal to 0. That what does it mean? That whatever may be the ionic strength you are increasing, there is no change in the rate constant. Therefore, in such cases, here you can say that the independent of such a reaction is independent of the ionic strength. Under this condition, log K is equal to log K naught, because here this term would be, this total is 0, because ZA, ZB is equal to 0, it will be totally 0. Therefore, now it is becoming log K is equal to log K naught. The third case, what is the third case? One is positive, that is A is having positive charge, B is having negative charge, or A is having negative charge, B is having negative charge. In both the cases, the slope is negative, and your equation is, your line would be just like this. What does it mean? That is, as the concentration of ionic concentration increases, the rate constant is decreases, or the rate of the reaction is decreased. Therefore, the inference is the rate of the reaction decreases with the addition of the electron or increase the ionic strain. If you understand this is a easier one, now you can give the answer for the problem. Now I am going to give. Take down the problem. Take down the problem. The straight lines are obtained. Straight lines are obtained for the salty effect on the following reactions. salt effect for the following reactions. Audience will take down the reactions. First reaction or reaction A. First reaction CO CnH3 5 times Br 2 plus mercury 2 plus. This is one reaction. Reaction B, S2O3 2 minus plus I minus. Next to C, CO C2 H5O N NO2 minus plus OH minus. Next would be CH3 COO ethyl plus OH minus, giving the product E H plus Br minus plus H2O and CEF CO NH3 5 times Br 2 plus OH minus FG Fe 2 plus CO C2 O4 thrice 3 minus. These are some of the ionic reactions that are taking place. Here we are going to give various log K versus the ionic strain. And forget this one. Sorry, forget this one. Because it is also this and this would be similar and change into G, U, E, F. Only 1, 2, 3, 4, 5, 6 cases are there. For one is a straight line. For another is this one. For another is this one. For the next one is like this. Then for this one. And for this one. Let it be A, B, C, D, E, F. Or correlate, which is equivalent to which one is which அப்படின்னு கண்டுபிடிக்க போறீங்க. You are going to match the reaction A and the in of these 6 lines mode, which is equivalent to for A, and B will be equivalent to what B, for which you have to find out only the slope of the lines by multiplying the charge over the A species and B species. Here on multiplication for the first one A, you are finding it out as plus 4 into 1.02, that is doesn't matter. Here if you multiply this 2 minus into minus plus 2. Here minus 1 into minus 1 plus 1. Here 0 and minus 1, 0. Here if this one plus 1 minus 1 into 0, 0. Here this one 2 plus and minus 1, minus 2. Here 3 plus and minus 3, minus 6. For this one, the D, for D is equivalent to D. Here slope is slightly plus 1. Here higher than this slope. Therefore steepness is increased. Here highly steep nature. Here also a low M is equal to minus 2, a low steeping. It is higher steeping. Therefore, if you compare this, A corresponds to A, B corresponds to B, C to C, and D to this, E to this, and so on. You can easily compare this one. This is the one matching problem and two more problem. Take down the first one. If the rate constant, of an ionic reaction, is 2O3 2 minus plus I minus, giving products is 4 into 10 power minus 3 per mole per liter per second in the presence of ions or in the presence of an electrolyte with ionic strain 0.04. What would be the rate constant of the reaction in the absence of electrolyte? Option A, in the absence of electrolyte, option A, 1.0 into 10 power minus 3, B, 1.5 into 10 power minus 3, C, 4.5 into 10 power minus 3, D, 5.5 into 10 power minus 3. On logic argument, you can immediately tell whether of these which are not possible. Before seeing that logic argument, we will see this log k is equal to log k naught plus ZA into ZB into root of I. Find out what is these things. ZA 2 minus and B is the value is plus. If the value is plus 1, the rate constant is higher than the K naught. We have already the rate of the reaction is increased. If it is 0, the log K is equal to log K naught in solid. If it is negative, then the K value is less than the K naught value. Using this logic argument, we can immediately say that for this reaction, the K value is higher than K naught value. This is the K value. It is higher than K naught. Okay. Or K naught value is always less than this value. Is not? When positive slope, you can write down this. Positive slope, K value is greater than K naught. Zero slope, K is equal to K naught. And negative slope, K is less than K naught. I have given in terms of rate, now I have given in terms of the rate constant. Now in the problem given, 2 minus and minus, therefore slope is positive. Therefore K naught should be less than K. K, it is given as 4 into 10 power minus 3. Therefore, which answers are not possible? Tell me if you understand the problem. Which answers are not possible?
A and B.
A and B is not possible. Huh?
C and D, sir.
C and D.
D is not possible.
Which,
C and D.
C and D. K here, K is greater than K naught, positive slope. That means K naught value is less than K. K value is 4. Therefore, K naught value should be less than 4 into 10 power minus 3. Here it is given 4.5. Here it is given 5.5. Therefore, your answer should be either A or B. Now work out it for this. We will work out for the one. And what is the value for the ZA into ZB? The value is 0.4. Okay. Then bring this here instead of log K log k can be written as 4 into 10 power minus 3. What is the value for log k value? This is for this 3 bar 0, 0, 0. For both, it is 0.60. Therefore, what is the value? Minus 2.4. Therefore, minus 2.4 is equal to log k naught plus 0.4, or log k naught is equal to log k naught is equal to, bring the 0.4 on the other side, minus 2.8, okay, minus 2.8, and k naught is equal to anti-log of minus 2.8. How would you take anti-log? 3 bar 0.2. Take the anti-log 0.2. What would be the answer? For 1 it is 0. For 2 it is 0.3. You have to take anti-log 0.2. Therefore your answer would be approximately 1.75 or nearly 1.5 or நமக்கு வரது 1.7 into 10 power minus 3. Therefore, the answer which is very nearest to 1.7 is the correct answer. Therefore, which is the correct answer? B is the correct answer. Option B is the correct answer. This type of problem is so far not asked. The last problem which is to be exercised in your home. The last problem, the rate constant for your reaction. The rate constant for your reaction between SN2 plus and Fe3 plus ions is found to be 1.5 into 10 power minus 2 per mole per second in the presence of 0.04, in the presence of 0.04 ionic strain, not 4 ionic strength electrolyte. What would be the rate constant? What would be the rate constant for the same reaction in the presence of ionic strength 0.09, ionic strength 0.09 electrolyte? How to approach? Here two types of data are given. First, what is the equation? Ionic strength is the equation to be applied is log k into log k naught minus, plus 1.0 to something ZA into ZB into root of I. First apply the first data, log k is equal to 1.5 into 10 power minus 2 is equal to log k naught plus ZA into ZB 2 plus into 3 plus 6 into root 0.04. This is first data. And second, what is asked? What would be the rate constant? That is log of k2 or log of x equal to log k when the ionic strength is increased to 0.09. This is the two sets of data. How to manipulate it? You can manipulate it. Bring the things another way. Log of 1.5 into 10 power minus 2. Here, if you bring this, minus 1.2 is equal to log k naught. I think so. Is not. And another, for this also, you can bring it as log k2 minus and 1.8 is equal to log k naught. Now, this log k naught the same. Therefore, you can equate this one, and after equating this one, the only unknown is K2. Find out the value of the K2. Find out the value of the K2. And this is the type of problem so far not asked. With this, I finish that the effect of salt on the reaction rates. And the next section, I'm going to discuss the kinetics of reversible reaction, parallel reaction, and consecutive reactions or sequential reaction. Please have an idea about these type of reactions. What are the problems that are already asked, that may be asked in future. Thank you very much. Have a nice day.